Evaluate the limit at x goes to infinity of x times e to the negative x. This is the product. We see that the limit at x goes to infinity of the first factor x is infinity. The limit doesn't exist, but it doesn't exist in a special way. The limit at x goes to infinity of e to the negative x is the limit at x goes to infinity of 1 over e to the x. The denominator gets very large, and 1 over a very large number is a very small number. So this is the indeterminate form, infinity times 0 or 0 times infinity. So we can use the L'Hopital rule. Regardless, even if we didn't check that, we can write it at the limit at x goes to infinity of x over e to the x, and we see that the numerator go to infinity and the denominator go to infinity as well at x goes to infinity. So this is the indeterminate form of infinity over infinity, so we can use the L'Hopital rule. In order to use the L'Hopital rule, we would need to rewrite the given limit in terms of a ratio, and that ratio needs to be either infinity over infinity or 0 over 0. So this satisfies the condition of the L'Hopital rule. To use the L'Hopital rule, we differentiate the numerator and the denominator separately without using the quotient rule. The derivative of the numerator is 1. The derivative of the denominator is e to the x, because the derivative of x is 1 and the derivative of e to the x is e to the x. We treat this as a new limit. To find this limit, we see that this is 1 over a very large number, which is 0. And so the given limit is 0. We see that the denominator is a very large number because at x goes to infinity, e to the x goes to infinity, and 1 over infinity is a very small number.